Oh yeah, I had that major test that we did, with the tag one where we went through everything. Yeah, I was really happy. I've like never scored this highly before. I got 49 out of 50. So
49 out of 50. That's
yeah,
excellent. Amazing. Beautiful.
yeah, the 1 mark though.
Congratulations, Amy. Now let's begin with another lesson. This time it is binomial theorem with rational exponents. We'll extend our learnings of binomial expansion. We'll take up integers as exponents, rational exponents, figure out what are the first four terms, and approximation of roots will be of major interest. Let us continue learning, connect, and explore with applications. Let us connect with what we know to where we want to go. Our approach, engaging minds, help us to perform much better. We can now connect to context, visualize strategy, apply learnings, and bridge the gaps. Engaging minds help in creative thinking and problem solving. Gain the confidence. Get ready for future. We develop both mathematical and social skills. I can be part of your success story. Build strong foundation and ensure bright future. That is the gift of education. You can always contact me on the email address given. Join my classes. Hi, Amy. How are you doing?
Hi sir. Yeah, I'm all right, thank you. How are you?
Very good, very good. So today, what do you want to learn?
I was hoping if we could start, kind of continue with the binomial expansions chapter. We did it a bit at school in terms of expanding and taking out one, and also the mod being less than one. And yeah, everything you taught like applied, and I could answer all the questions, so that was really good.
That's very good. So, how has been your performance so far?
Oh yeah, I had that major test that we did, with the tag one where we went through everything. Yeah, I was really happy. I've like never scored this highly before. I got 49 out of 50.
49 out of 50. That's
Yeah.
excellent. Amazing. Beautiful.
Yeah, the 1 mark though. I know it's really bugging me, but it was really hard, and like no one got it. It was because there was a formula, the geometric sequence formula. It has n-1 in it, so I applied the same thing in the systematic approach. I got the right answer, exactly the way they wanted. It's just they wanted n, and they said it's in terms of the wording. So let's say again with the English, they just played on the English. It was in the English, not even in the maths.
Good,
So
good.
yeah. But
Yeah, so
yeah,
they
thank you so
remind you
much.
you are in England. They remind you you are in England and they own it.
Yeah, they own the English words, so they play on that. But yeah, thank you so much, sir. That was all the prep that we did in revision. It really paid off.
My pleasure, my pleasure. And keep it up. This is the right time to peak. And I I hope that in university also you talk. That'd be great.
I hope so too, sir. I won't like stop contact with you. I'll always remain with you, sir, helping, being there beside you.
So, okay, let's begin with our lesson. So, share with me whatever you have and we'll continue from there.
It's quite a short chapter, this binomial expansions. So
It is an extension of your previous binomial expansion, right? So that is
Right.
why it is short, because you did in year 12 everything about it, and few things which are special cases, you are doing it now in year 13. That's the whole reason, right?
All right. So we covered that last top part last lesson. Example here we could go through, or
Correct. So this example is very interesting. Can you please read the question?
yeah. So find the first four terms in the binomial expansion of a, which is the square root of 4 plus x, and then b, which is 1 over 2 plus 3x whole squared.
Correct.
And then state the range of values of x, which these expansions are valid.
Perfect, perfect. So, well, let me tell you, before we get into details of this, you're trying to figure out what is the value of square root of 4 plus x, right?
Yep.
Now with the expansion, you'll get some approximate answer. So let us say x is equal to 1. That means you get the value of square root of 4 plus 1, which is square root of 5. You see,
Yeah.
square root of 5 is irrational number. Now with this expansion, you know the value of square root of 5. And similarly, you know the value of any irrational number using this expansion. You get the idea. So it
Yeah.
could be a method for finding or estimating very accurately, estimating up to 2 or 3 decimal places, values of any square root. You get the idea. So keep
Right.
that in mind, because sometimes that could be the question. The question could be, find the value of square root of x, 5. I'll not give you this expression. I'll say, Abby,
Oh.
find the value of square root of 5 to 3 significant figures.
Yeah, you can't just plug in the calculator right there.
Now what you have
Yeah.
to do, you'll say, well, square root of 5 really means 4 plus x square root, where x is equal to 1. You get the idea?
And then you will have to solve and then
So
say something
whatever
in
question
x
you've
is
done
1.
just now, you do all this and plug x equals to 1 and get your answer.
Right. Okay.
So remember, you could be asked in this fashion also. Okay.
That'll be really hard to suss out that it's part of this, because there's no indication that it's to do with binomial expansion because you're working backwards.
No indication that it is related to binomial expansion, and that is why questions related to binomial expansion are very tricky. After the exam, only students understand, oh my God, in that question, we have to apply binomial expansion. I've heard it so many times.
Oh, okay. I'll make sure not to be part of that group who says that. Okay, I've heard it here first.
So whenever you have radical roots or even negative roots, then this special case of binomial expansion works. And if you get stuck, think about this and get your solution. That's what I'll guide. Is it okay?
Yeah.
Perfect. So now we have to find, first 4 terms of the binomial expansion square root of 4 plus x, right?
Yeah.
You have to give first 4 terms. So basically, you have to write this in terms of, you can write this as like 4 plus x to the power of half, and then you can factor out 4 as you will normally do, as has been done here also. But what I'm just trying to show here is that, remember, when you expand this, of course, square root of 4 is 2, so I'll take this out, and we have 1 plus x over 4 to the power of half, correct?
Yeah.
Now the thing is, here we have a restriction, and that is that x over 4 absolute value has to be less than 1, correct?
Yeah.
So this provides a restriction on the value of x. X cannot be like more than 4, correct?
Yeah. So mod of x is less than 4.
Mod of x, mod of x is less than 4, yes. So that becomes a restriction. So when you work on these questions, you have to keep all these things in mind while you're working, correct?
Right.
And we can, of course, apply the formula and expand, simplify. That's not a difficult part once you know the formula, correct? So let's go through the solution right there. So first portion, square root, they have written as 1 plus x to the power of 4 to the power of half. And now look at the expansion, right? Always in the expansion, it is 1 plus. Whatever is the exponent, you begin with the exponent, right? n times n minus 1, because the formula is n times n minus 1 times n minus 2, and so on, right?
Yeah.
And in the denominator, the factorial term is number of terms you have multiplied in the numerator. If there are 2 terms, then the factorial will be 3 factorial. Is that okay?
Right. Yeah.
And the sequence is divide by 1 factorial plus divide by 2 factorial. So it gives you a sequence in mind. So if you keep these things in your mind, then solving binomial theorem questions become very simple.
Right. Yeah.
So let's go through this once again. So we have 2 as a common factor, and inside 1, and then exponent half times the next term, which is x by 4, correct? Done.
Yeah.
And then the second term is half minus 1. Do you see that? N minus 1? Because n is half for you. So half minus 1. Since you have used 2 numbers product, half and half minus 1, you have 2 factorial in the denominator, correct?
Right. Yeah.
And then the term which you have, x over 4, power will increase 1 by 1, right?
And the factorial term is also the same as like x squared, x cubed. Yeah,
correct, correct. Do you understand now? Do you understand how we have to
clear
do
pattern?
So
yeah,
because you want 4 terms, you go up to cube because the first term is 1 constant.
1. Yeah. Don't go up to
R
x4
plus
because
right.
don't forget about the 1. Yeah.
Yeah. So when we are looking into number of terms, so if the number of terms you want 4, then your only exponent is r. R is 3 only. Do you understand? Because r to the power of 0 is 1, right? So that is your first. So all these things should be connected while you solve this. Well, let's go through this solution, which is right before you. So when you expand, you get the result, which is 2 plus x over 4 minus x squared over 64 plus x cubed over 512, correct? So you get your result. This is perfectly fine, correct? Now, they have also mentioned here, expansion is valid if absolute value of x over 4 is less than 1 or absolute value of x is less than 4, correct? So we could use plus or minus 4.
Yeah. Right? I'm just laughing because we calculated all of that ages ago before the question. We even read the question. Yeah. Which we always do, even with domain and range and so many things. Yeah. We just do it immediately first, but even if they ask or don't ask.
Yes. Yeah. Otherwise, see, the thing is, once you get the answer, you like to move to the next question. Why will you sit? Very simple, right? I will not sit there. I'll go to the next question. And in doing so, I'll forget that I did not mention the restriction. Right.
And then your answer could be wrong if it's not within the domain or the range. So it's so important you start with that.
Yes.
It makes sense.
Once you start with that, it sticks in your mind. Oh, the restriction is this. So let me check. Is my answer within the given domain?
Definitely.
Question.
Yeah, because before you told me that I had to do that in the beginning, honestly, every test that I did, every mark that I lost was because it wasn't within the domain. Like method and everything's all right. It's just because it wasn't either in the domain or the range. Because you just forget that you just think all the answers are there, done. You literally forget that it even exists, that there's something called domain or range. But the moment you told me onwards where you have to start with it, not once have I ever lost a mark based on that. Like not once. If something else, then yes, but not on that. Correct. So it's so important.
Getting above 90% is making sure that you do not miss out on these important simple things.
Right. Yeah.
Otherwise, you cannot get 90 plus. Very simple.
Yeah.
Great. So you have understood the method. It's already an example here how you learn few tips, and that is whenever you're expanding, let's say they're asking for 4 terms, highest power is going to be 3.
Yeah.
Right? Basically, one term over 1 factorial, 2 products, product of 2 over 2 factorial, product of 3 over 3 factorial, correct? And the term, which is like x whatever, increasing powers from 0, 1, 2, 3, done. So that is the expansion. If you keep this in your mind, you are all set. You cannot make a mistake. Okay, so
you don't need to sit there and learn the formula as long as you understand. Because that would take a long time. There's too many formulas to remember. If you can just make it easier for yourself.
So the second question you are not doing, you can do that on yourself, right? There was 2 parts. You can do that. It's very similar. All my students to try this out. Okay, show them to try this question out. And of course, you are going to write this as 1 over 2 plus 3x whole square. Really means you write 2 plus 3x to the power of minus 2. Remember that. And you can factor out 2 here. That means 2 is factored out. So you get 1 plus 3x over 2, right? Everything to the power of minus 2. And then you can factor 2 out, right? So 2 to the power of minus 2 is quarter. And then you get 1 plus 3x over 2 to the power of minus 2. Before you expand, write down that the absolute value of 3x plus 2 is less than 1.
Yeah.
You get the idea?
Yeah, really clear.
Simple
Do we
as
need to write it in terms of mod x, or can we just leave it like that?
mod x. Because otherwise
Oh.
you write like this. You write 3x over 2 is less than 1 and greater than minus 1. Either you write like this,
Oh,
or
okay.
in terms of mod x. Mod x is better, right? So you can
Yeah.
simplify this and you say mod value of x is less than 2 over 3. You get the idea?
Okay.
So that's simple. So that becomes your restriction on x. Do not forget this. That is what I'm trying to say. Other things I know, you can apply the formula and get the result. Is that okay?
Yeah, clear.
Now let's look into the second type of questions which you have. Using partial fractions. I love this topic. Can you please read what this example is talking about?
Yeah, so partial fractions can be used to simplify the expansions of more difficult expressions. So example 7, express 4 minus 5x over 1 plus x over 2 minus x as partial fractions.
Yes.
And then part B is show the cubic approximation for 4 over 5x minus 1 plus x over times 2 minus x is 2 minus 7 over 2x plus 11 over 4x squared minus 25 over 8x cubed.
Correct. So they are saying, see the wordings. They are not telling you to apply binomial theorem anyway. You get the idea.
Yeah.
Now read this. They are saying cubic approximation. How do I get from partial fractions to cubic approximation? You get the idea?
Yeah.
Radical. Radical. Because in binomial expansion, you had increasing powers, right? 0,
Yeah.
1, 2, 3, 4. So that means 4 terms. That means fourth term will have a cubic power.
Yeah.
Fourth term. And you see the answer: first term, second term, third term, fourth term. So there are 4 terms in it. Fourth term has the cubic power. You see that?
Yeah, yeah.
Now you understand the link between any term. It could be a partial fraction or whatever, right?
Yeah.
I could even call this like 1 over x, 4 plus x, you may write like this, right? As a partial fraction part, right? One term of partial fraction, correct?
Yeah.
And we did last time cubic term.
Oh.
We did last time cubic term, correct?
Yeah, yeah, we did.
But they told you to do it, and therefore you did it. This time they are not saying that. Please read this.
So hence show that the cubic approximation of 4 minus 5x over 1 plus x times 2 minus x is that. Yeah, so they're not saying, use binomial.
In examination, it is not chapter wise. Like you are doing binomial expansion, therefore, obviously, you have to apply binomial expansion. No.
Yeah.
It is like question number 10 in your question paper.
It's so random, broad. Yeah, you have to think with your own head.
So every approximation, square root, cubic, whatever approximation you're doing, if that comes, it is binomial expansion. Cubic means 4 terms because the first term has got power of 0, x2 power of 0. Second term, x1, x2, x3 will be the 4th term. So you get cubic means you have to go up to the 4 terms.
Right.
Binomial expansion. Is that part clear?
Yeah, it's because they said, so when they say approximation, they mean binomial expansion because we use binomial expansion to make approximations, right? Is that why they use
only it is an infinite series. Remember, that is whenever you're talking about negative exponents or radicals, right? This is an infinite series. Do not forget that, right? So in this infinite series, we go 1, 2, 3, 4 terms, we add them up, very good. And then other things we are forgetting, correct?
Oh, the negligible
approximation.
Yeah. Oh, because they go to 0, yeah.
For any infinite series, it will be an approximation. You cannot go till infinity, correct? So it's always an infinite. So the word approximation in itself is a key reminder for you to look into binomial expansion. Is this part clear to you?
Yeah, really clear.
Very important. You may lose 10 marks just by not knowing this.
Yeah.
Now let's get into the easy part of it. That is partial fractions, right? So if I have 4 minus 5x, I know it's been solved, but let's think about it. 1 plus x times 2 minus x, right? How will you do partial fraction? How will you write this? Now you see that the degree of denominator is 2 and degree of numerator is 1, correct?
Yeah.
Therefore, when you divide, you cannot get any linear term. You will always get a constant in the numerator. Correct? So they are saying the constant, because there are two terms in the denominator, one will be, let's say, a divided by 1 plus x plus b over 2 minus x. Is that okay? So that is how you get the first term itself. And then, of course, you take the common denominator so that you have 1 plus x times 2 minus x, and you multiply a. This is like cross multiplication, right?
Yeah.
And 3 times 1 plus x. Now, to simplify this, what you have to do is, if I put x as 2, then this term is 0, right?
Oh, yeah.
If x equals to 2, then the first term is 0. But if x equals to minus 1, then the second term is 0. Is that okay?
Right. Yeah.
I mean, this is b, right? Then the second
B.
term is 0. So accordingly, you can find the value of a or b using which term multiplied by 0. Is that clear to you?
I see. Yeah.
That is the strategy. So let's go through the solution now. Amy, can you please read the solution?
Yeah. So here they've got exactly what you said about common denominator and multiplying a and b by their,
Cross multiplication.
Yeah, cross multiplying, making that equal to the initial, numerator of the fraction, which was 4 minus 5x, and then we're substituting x equals 2 to cancel out the a, the bracket that is multiplied by a, because 2 minus 2 is 0. So that means when you sub in 2 into the 4 minus 5x equation, you get 4 minus 10 equals 3b. And then you get 3b equals minus 6, and then b equals minus 2.
So basically, they are only comparing the numerators. Do you see this expression on the left-hand side? So on the left-hand side, we have 4 minus 5x over 1 plus x times 2 minus x, correct?
Yeah.
So basically, first step is you cancel these terms in the denominator. Do you see that? Both sides. Then you are only comparing the numerators, right? So.
Oh, that makes sense. Yeah.
So when you are comparing the numerators, you have 4 minus 5x on your left-hand side, correct? And rest of the terms, which is a times something plus b times something, is on your right-hand side, correct?
Yeah.
So as soon as you substitute something for x, in that case, and you make this 0, you get the value of b.
Yeah.
And if you make b 0, you get the value of a.
And then you can find them a and b.
Once you find a and b, which in this case is 3 and minus 2, you have done partial factoring. That is first part.
I like that. Yeah.
Correct? So you have understood the whole concept behind it? Very good. Now, second part is to approximate the value to cubic approximation. That means what? See what they have done now. You have this expansion 3 plus 1 over x. So 3 plus 1 over x has been now expanded using binomial expansion. Do you see this part?
So when you see binomial expansion, no, when you see approximation, you think binomial expansion.
Yes.
Well, when you say that cubic, you should.
Correct. 3 times 1 plus x to the power of minus 1, and you also have minus 2 times 2 minus x to the power of minus 1. So these are two parts.
Yeah.
Which you have to expand and add.
So you individually solve for each.
Each, yes. Get your four terms, right? Individually solve each, get 4 terms. Is it okay?
Yeah.
And then get simplified.
Get 4 terms, yeah, and then simplify.
To get the result. You get the idea, right? Then you get this result. Is that part clear to
you? Yeah.
That is how you
I'll be around 10 marks, like you said.
Yes. Now you understand, right? So this
so I think everyone can do obviously the first part because we've heard of partial factoring, we know the steps. It's the second part when they say cubic approximation, your mind doesn't go to binomial expansion at all. But now you've mentioned it, it's now stuck in my head. But yeah, it's really key point, that one.
Yes. So finding roots, this is like approximate value of roots, right? Root could be third root, fourth root, fifth root, whatever. You could do using binomial expansion. That is what.
Yeah.
And it all depends on number of significant figures, right? So normally you are interested in 3 significant figures. So 4 terms are more than enough.
Yeah. Okay.
So that's the whole idea. So therefore, I think they are going up to cubic. Is that okay?
Yeah. If they don't mention to like how many terms, should you just go to 4? Because I did have a couple questions like that. Do you just do 4 terms?
So let's go back to this question. Let's go back to this question. I will reframe it, okay? So this is one way of writing it. Hence, show that the cubic approximation is this. They basically want you to simplify into this formula. So they are looking into your algebraic skills. Do you understand?
Yeah.
They want exactly what this expression is. So you have to expand both the terms, combine them, and simplify and get the result, right? Now,
Yeah.
they could also say at this term, find the value, evaluate. They can use the word evaluate, evaluate or find the value, right? To 3 significant figures for x equals to what? So you have to see in this expansion, what is the restriction on x? You get the idea?
Yeah.
You do 3 times 1 minus x, you have to find what value of x you can get into, right? And so they'll say when x is equal to that, find the value to 3 significant figures. So 3 significant figures, you might get that value only in going up to 4 places, 4 terms.
Yeah.
That's the whole idea.
Oh, right. Okay.
So if you say 2 significant figures, go to 3 terms, n plus 1, and get your answer.
Okay. Yeah, that's clear. Yeah.
Correct. So
okay, that's really key point. Yeah. Also, sir, I just want to mention again, when you said about the root 5 and how they can reword the question. That's a really key point, because I would never have thought that they could ask a question like that, because that would throw everyone off. So yeah, let's
see your exercise. I think let's see. Let's show your exercise. Let's see the questions in here. Oh, wait. You have. Oh, can you please read question number 3?
Which one?
Question number 3.
Okay, so give the binomial expansion of 1 plus x to the power of a half up to and including the term in x cubed.
That means 4 terms, right? Okay, next.
Right. Yeah. By substituting x equals a quarter, find an approximation to root 5 as a fraction.
They are giving you a hint. By substituting x equals to 1 by 4. In my school, they will not give me this hint. They will say find approximation for square root of 5.
They're still holding our hand. Yeah, so at this point, you would have to do the square root 4 plus x, and then x equals, similar kind of approach. Oh, okay.
So, very tricky question. See, 1 plus x to the power of, what is that? What is, I cannot read this.
1 plus x to the power of a half.
Half, right? They're saying you put 1 plus x as 1 over 4, because we have a restriction that x has to be less than 1, right?
Yeah.
Now look at this term. It becomes 4 plus 1 over 4 to the power of half. You get the idea? So that becomes 5 over 4 square root, right? So you have square root of 5 and you have half outside. So ultimately, you're finding the value of square root of 5. Do you see this?
Oh. No, I would not have seen that. What? That's like that thing that they did before, with the 49 and the 2.
Yes. With the square root of 2, right? You remember?
I don't like this. It's numbers within numbers.
It was 0.98 square root, right?
Yeah.
And they wrote
49.
They wrote it
98 over 100.
98 over 100. Very important, right? So 98 is what? 49 times 2.
Times 2. Yeah, but how would you see that?
100 is 1 over 10. 49 is 7. So 7 over 10 square root 2. Do you see
root
this?
2. Yeah, that's just, I don't know. Numbers within numbers. They're too much.
Now look at it. So there is no need to just practice binomial expansion. There is need to understand the type of questions which can come in the examination. And this is what it is. Square root of 2, square root of 5 value. You get the idea, right?
Yeah.
So read this question. Find an approximation of square root of 5.
As a fraction, yeah.
My school, they will say up to 3 significant figures.
And then you would do to 4 terms.
They will not tell me x is equals to 1 over 4. No, not given. Not given. Okay. You have to think about it. Think. And then use this value. And then they will say three significant figures, right? You don't know how many terms to go. You have to go for 4 terms. You get the idea.
Yeah, plus 1 to the SF. Yeah.
Then you get this answer. Right? Then this
Oh.
will be not 5 marks, but 10 marks. Because you have to get the value of x. You have to understand how many terms in binomial expansion. You have to figure out that this is binomial expansion in the first place.
Yeah. So overall, much harder your way. Okay. Okay. So do you mind just going through 3, just so that I have a clear kind of method in my head when it comes to this?
So basically, you have 1 plus
Let me just
x to the power of half, right?
1 plus x.
You have to find it. Can you read the question once again? Then we'll go through it, right?
So give the binomial expansion of 1 plus x to the half up to and including the term in x cubed. So 4 terms. Yeah. So that's fairly straightforward.
Let's expand this, right? So this is 1 plus. Now first term will be what? Half is your exponent.
Half x.
Right? And x, right? Plus second term, you have to do half times what?
Half minus 1.
Minus 1, right? Times
over 2 factorial.
Square, and this is 2 factorial. Is that clear to you, right?
Yeah.
Plus half times half minus 1 times now
half minus 2.
Half minus 2 times
x cubed over 3 factorial.
You have reached x cubed, correct? You stop.
Yeah.
Is that clear?
Clear.
So this is equal to this, correct? Now you can always multiply what is half times this. Not a big deal, right? You can always do 1 plus half x plus half is like 3 by minus, of course, minus, right? So minus half times half is minus 1 over 4. Let me write minus 1 over 4 here, right?
Yeah.
Square.
Divide.
And 2 factorial is 2, right? So we'll keep 2 here for now. And then next term will be, so alternate plus and minus will come thereafter because of this minus exponent, correct? Now you have, we know the product of the first 2 terms. We have to multiply that by minus, because 3 by 2, right? So if I multiply this by minus 3 by 2, it becomes plus. And you get 3 by 8. Is it okay?
Yeah.
And you have x cubed by 3 factorial, which is 3 times 2 times 1, which is 6. Is that clear to you?
Yeah.
So you have this term, right? Now, you can always add this up and then simplify. So you get 1 plus half x minus 1 over 8 x squared plus. You simplify this 3 times 16, right?
1 over 16 x cubed.
So that is your answer of the first term. Is it okay?
Yeah.
So you got the first part. Now substitute x equals to 1 by 4 in all these terms, right?
Yeah.
Then they are saying find the approximation of square root of 5. So you'll do like this. You will say 1 plus 1 by 4 to the power of half is equal to, you have on the right hand side 1 plus half times, this is right hand side I'm writing, x value being 1 by 4, right?
Yeah.
Minus 1 by 8 times 1 by 4 square, correct? Plus 1 by 16 times 1 by 4 cube. Is it okay?
Yeah, that's clear.
Now substituting the left hand side, left hand side, if you take common 4, right? So you get what? You get 4 plus 1 over 4 to the power of half, correct? Yeah. Right hand side you can evaluate. So you get a value. Now on the left hand side, you have square root of 5 over square root of 4, correct? Square root of 4 is half. So half square root of 5, correct? So you get square root of 5 is equals to 2 times all this, whatever you get.
Right.
Is that clear to you?
Yeah. So most people won't, because I don't think that they would see, like even I didn't see the term, you know, when expanding that, I just thought that it will work out to be root 5 for some reason. I don't know why, because I think either I have x plus 4 in my head and thinking x is 1, or I'm just thinking that it would just work out. So I wouldn't see the 2 to multiply it back. I would just find the value and then just solve.
No.
Like all I'll do is do it and then put a quarter into the equation, and I think that's the answer. So
No. Yeah, you have to multiply
like
by
stop.
2. Correct.
Yeah,
Correct.
yeah, that's the last part. That's why I'll lose the marks. I
Oh
don't
my
want to
God.
lose the mark.
Oh, yes, yes, yes. So
Oh.
there are so many places where you could go wrong, right?
Let's starting off with not knowing to use binomial expansion. Yeah, and ending with the times 2. Okay.
Correct.
Okay.
So you could get half the answer.
Yeah, that would be really sad because you've done most of the work.
Yes.
Okay.
Ah,
Oh my God, thank you so much, sir. Okay, that was really helpful. I think I can complete the rest of the questions in my book, and then I'll
perfect.
let you know if there's any issues.
Yeah. They put 1.45 there. One question, 1.45. So you have to write it
Oh, did they?
as a fraction. Very
Oh
interesting.
no,
No, don't worry.
I just saw it.
Yeah, you saw
Yeah.
it. That is good to see all that because it reminds me of what we went through, all that, correct? And I remember
Oh,
places where we got stuck. So that's what I'm sharing with you. Basically, it's not that I know it. It is known to me because I failed myself in catching them early on. You get the idea?
right.
No one told me that you have to see all this in this fashion.
Yeah.
Only
And they don't even say it at school either. Maybe the teachers have also experienced it, but they don't tell us. They just wait till you suffer and you go through it. It's really rude, but it is what it is. Yeah, and the issue is that teachers tell us like all the mistakes after the exam's over.
Yeah,
what benefit is there for me?
It's like postmortem. Like who cares now? Move
Yeah,
on. Let's do something else.
Because when we needed the help, you weren't there to help us. Now you want to help us, and we don't care because it's all over. Yeah. Well, thank you, sir, for mentioning all those key points because I'll make sure not to make any of those mistakes since
So
they're in my head.
can you repeat those couple of key points which one should keep in mind while working on such problems, especially binomial expansion?
Yeah, so I think the main thing that I took away was in terms of wording. We know how, the English language and they like to play on words, but in certain cases, especially like I know my exam board, they do help you in terms of kind of guiding you with your hand, and they still did partially, but this is kind of the hardest they've been in terms of when they said cubic approximation. They're not stating anything, no indication that it's to do with binomial expansion, because this question, like you said, it comes in my chapter of binomial expansion, but in the real exam I'm not going to have any indication of where this is from. I'm just going to have to know and use my brain and apply things, and we saw different kind of approaches. So let's say they say work out to the best significant figure of what root 5 is. You need to go back and backtrack to like initially forming the equation yourself. If they say find it to x cubed, you need to know the number of terms is like 4 terms, because including the first term, which was 1, because it's r to the power of 0. So that's one of the things you bear in mind. And then also the last part in terms of, like we saw the 2 examples of how you can find root 5 or even the root 2 from the, the 0.98. Yeah, you can find those values within other values when you take out, factors or square roots, and when you take them all out, it will simplify into just root 2 or something. And so calculating those values, but multiplying it back by 2, or, formulating the equation as a whole, those are really key things, and you don't want to be losing marks on that. And obviously the main thing is when you're doing binomial expansions, just remember to write down the restriction, the domain, which is the mod of x being less than 1. So whatever it may be.
So let me emphasize on the fact that when they're asking for 3 significant figures, you have to use 4 terms. Imagine you expand everything only to 3 terms, and at the end, you do not get your result approximated to 3 significant.
Oh my God!
The whole effort is lost.
Waste time. Yeah.
You need to go back at the 4th term and then come down, and you have lost time for another question. Imagine.
Can't even think of that. Yeah, it's too much.
Therefore, these simple tips are actually critical. They make huge difference. Okay.
Yeah,
So that's
maths,
the whole idea.
maths is a subject where you never ever have time to check. Because I've done so many, tests in the past, especially like being in through GCSEs and A levels and doing like English and everything. There's those subjects. There is always time to maybe go back and check a thing. But because maths is just it's just too much to do, and there's not enough time. And especially if you make an error, the amount of time you spend like recorrecting, just suddenly all the time's gone, and then you've got the rest of the paper to go. So you have to be really like on top of it. So yeah, it's really important. Yeah, for special maths.
Great. And once again,
All right.
congratulations, Emmy, for getting 49 out of 50. I love that. So that one
Thanks.
mark will
I
keep
couldn't have
you
done it
going.
without you.
My pleasure. All the
Yeah.
best.
All thanks to you, sir. Thank you so much. Enjoy the rest of your day.
You too. You too.
Bye, sir.